Welcome to Relay Chain, a podcast produced by Parity Technologies where we discuss all things substrates, Polkadot, and Web3. Today on Relay Chain, we have Gautam, our solutions architect at Parity, and in a twist, he is going to be interviewing me, so I'm going to let Gautam take it from here.
Hi everyone, welcome to this new episode of Relay Chain podcast. And I'm your host today. I'm Gautam Dhameja. Like Joe mentioned, I am a solutions architect with Parity. As you might have seen and heard that there is a canary network for Polkadot coming up very soon, or I'm not sure. By the time this podcast gets released, it might already be there. So Kusama, the network, and there are some important questions about how do I become a validator? What should I, learn before doing that? What are the must-haves? What are the misconceptions and so on? And we wanted to talk to Joe, who's actually also working in this direction, helping the validators get up and running and get started on these processes. And he's the best person to talk to about knowing more about these things. So that's why I'm interviewing Joe today on his podcast. So let's dive in and learn more about becoming a Polkadot or Kusama validator. So Joe, welcome.
Thanks, Gautam.
Let's quickly understand a little, and we'll jump right into it. I wanted to understand a little bit about what does a validator do in context of Kusama and Polkadot.
Yeah, so I think we can kind of even go out of blockchain for just a minute here and just talk about, because validators they're helping the network come to consensus. And so what is consensus? And consensus algorithms tend to be a defined series of messages that make a network of computers appear as a single computer. So it shouldn't matter how you connect to the network of computers or which one you talk to. If you ask a question, you should always get the same answer. And this can sound a little bit abstract, but if you think about it in something like a physical space, if you have an airplane, there'll be multiple computers because things that have humans in them tend to have redundant systems. And so if you ask the flight computer, what direction am I going? It shouldn't matter which part of that network you ask. You should always get the same answer because it's very obvious to see that an airplane can only be going in one direction. And so consensus is just an algorithm that is a series of messages of how to get a network of computers to look like a single computer. And that's really our goal here. And the validators are passing these messages. In the context of Polkadot and Kusama, we have these algorithms that work together. They're called Babe and Grandpa. Babe is for producing blocks and proposing what the next state change should be. And Grandpa is for finalizing it. And so I think we're going to be talking a lot about staking and rewards and punishment here. And the main thing to keep in mind is that the reward and economics part is different from consensus. So consensus just defines, these are the actions that we want you to do. We want you to produce valid blocks. We want you to check that they're actually valid. And we want you to agree on which ones are final. Things that are bad might be signing or voting for two blocks that actually conflict with each other or proposing a block that's not valid. And so when it comes to staking and slashing and rewards, we're really talking about how do we respond to messages that consensus defines as good or bad.
Interesting. So in that case, if I understood that correctly, and just to rephrase it for our listeners, in context of Kusama and Polkadot, a validator would be doing two things. One is making sure when the time comes, when you have the opportunity, produce the next block and vote on finalization of the subsequent or the previous blocks. So whenever your opinion is needed, you vote for a block which needs to be finalized. And whenever you get an opportunity, because it's a round robin approach, I believe, that to produce a block, or it's a random approach in Babe, right?
It's both. It's a random approach with a round robin fallback so that we can get a constant block time.
Interesting.
And I would say there's actually one more thing that I missed here, and that's very Polkadot specific, in that validators are responsible for passing messages between parachains. And that's something that doesn't exist in a single blockchain. But when you have multiple blockchains, the validators have this additional responsibility of sending messages between them and making those messages available for reconstruction.
Interesting. So in that case, there are now three things that validators do. One is produce a block when you are asked to do that. vote on previous blocks which need to be finalized, and then pass messages between different blockchains.
Yes. And I would say we have a nuance here in that we're not really voting on blocks, but we're voting on chains.
Okay, interesting. So we are considering a chain of blocks to be finalized instead of a single block.
Yes.
Awesome. That's so efficient
Yes.
in terms of getting finalization.
So you could actually vote on a block that's 5 blocks ahead of the last finalized block, and it will add those signatures and votes to the blocks that are behind it, and it can finalize all of them at the same time.
That is, if I think of it in a different way, that is so freaking amazing, because you are actually using the characteristics of blockchain to finalize the blockchain.
Yes.
Wow. And this is something, and I just want to call out that our colleague Ben, he actually pointed this out to me when he was explaining Grandpa to me. So yeah, pretty cool. Okay. So now that we know that what a validator does, we also want to understand a little more about accounts, keys, and tokens over here, because before we jump into staking and nomination, like you mentioned, there are these things involved. What do you stake? How do you control that? What is the, how do you access those? How do you sign your message and everything? For that, before we move into, because staking and nomination will require a lot of function calls and messages and so on. So before that, we want to understand the accounts and keys over here. So maybe just give us a brief about those things.
Yeah, so Polkadot has 2 general types of accounts, a stash and a controller. And you should just note upfront that the difference here is purely semantic. It's the same type of cryptography, same type of key pair. They can actually be the same account, although we don't recommend doing that. The distinction is really only in how you use them or how we want you to use them. The stash account is something that should generally be kept offline. This would be like where you keep your life savings or large amounts of money that you don't intend to move. But if you're participating in governance or nominating, you want to be able to nominate with this stake. But you don't want to sign a lot of messages with this key because that kind of inherently makes it vulnerable to being captured by somebody else. So you really only have to sign one message with your stash account, and that is a certificate. And so you take the public key of another account, which we call the controller, and you just sign a message from your stash account that says, you know what, here's a public key of another address. I want this to be my controller. And in this controller account, you can put a very small amount of funds, like just enough to cover transfer fees, or I guess it would be transaction fees because not every transaction is a transfer. And this controller key gets to just tell the system what you want to do. So it can say, I want to nominate this validator, I want to validate myself, or I want to vote on this governance proposal. And it has the weight of the stash account because it got permission to do that. But the funds aren't really at risk because you're not signing these messages with a stash account. You're signing them with a controller account, and only this very small amount is at risk. And so if you get concerned that maybe your controller account key was seized by somebody else, you can just change it and designate a new controller for your stash account.
Okay, so we have 2 accounts, and one is called the stash account where I have majority of my funds associated, and second account is the controller account, which is basically more like an operational account for controlling or managing operations or like functions on the chain. And these accounts are associated together by calling or by signing a call using the stash account.
Yes.
Okay, interesting. So, and then that makes the whole thing a little more secure, because once you have your stash account, you can literally, after associating a controller account with it, you can just keep it aside and keep it in a very secure and safe place. And then from there on, your controller account is the main thing that you want to work with.
Yeah, that's right.
Okay, interesting. And now let's go into a little bit about the session keys, because that's something really interesting. I still could not wrap my head around what they are and how they function. So let's understand a little more about them. And before that, tell us a little about what exactly are session keys.
Yeah, so session keys are a very abstract concept at first. So it really helps to talk about them just as a concrete example of how we use them in Polkadot. And the more abstract, you can just kind of declare however many session keys you want in a blockchain using Substrate. But in Polkadot, we have 4. And so these keys, you can just declare and say, I want them to be associated with some sort of message that validators perform. And It should be noted that these keys are not meant to be accounts. So they don't have to be the same cryptography that an account uses. They can be completely different, although at the moment they're not. These are just for signing messages. So these are not associated with funds at all. So in Polkadot, we have 4. We have one for Babe for the block production. We have one for Grandpa, which is finalization. We have one for I'm online, which is sort of like a helper message. It just, you tell the chain every couple hours, like, hey, I'm here as I'm supposed to be. And then we have one called Parachain ID, which helps match the validators with parachains so that they can find each other.
Interesting. So if I understood that correctly, we have 4 session keys, and the basic function of these session keys is to kind of show your identity or prove your identity in different contexts. So let's say, for example, for Babe and Grandpa, you want to show your identity about I am this particular validator for these different contexts. And then for I am online, like showing that I will be signing my messages for being online or for showing that I'm online by using this particular key. So that will identify me as a validator again for in the I am online context. And finally, you mentioned something about parachain ID or something like that, right?
Yeah. So this helps the parachains and validators find each other and know who they're talking to.
Okay. Interesting. So then again, basically, it's all about identity. So session keys, I would say that they are primarily for proving the identity of a validator in different contexts, and they are all separated out from each other so that they can be easily like changed or maintained or like just for more control. Because having 4 different session keys, how do you maintain those session keys?
Yeah, so there are 2 general ways to do it. So I guess first, you're right, like these are about linking what your validator is doing to your validator. And so just like you assign your controller accounts by signing a message from your stash, you're going to tell the network about your session keys with your controller. So after you tell everybody that you want to be a validator, you're going to take all 4 of your session keys, the public half of them, and sign that message with your controller account. And that says, these session keys are the keys that I'm signing for my validator, which is tied to my stash account. And so when the network gets a message from you that says it was signed, a grandpa vote on a chain finalization, then it can say, okay, like this vote comes from this stash account because it's linked to this session key.
Just for the understanding of our listeners and also for me personally, that when I am having 2 accounts and 4 keys, how do I make sure that I am not, doing something wrong or doing exactly the thing that I need to do with them? Yeah,
so this gets a little bit more advanced than maybe your normal user would do. So this is definitely focused on validators. If you just want to nominate, this is not something you ever have to worry about. So the way you would generate these session keys is by calling an RPC endpoint in the actual node that you're going to be a validator on. And it will generate these 4 keys for you and put them in the key store that is contained within the client. And it will give you back as a response all 4 of the public keys. And then you can sign this message with your controller that associates your node with your controller. And then these keys all get managed within the client. So after you do that, you don't really have to worry about it. You've already told the chain that these are your session keys and they're in the client, and your client will actually know which ones to use. So it's a pretty simple example. When you first start, you just do it once, but then you can change these keys every session. And so you can generate a new set of keys just by calling this RPC and then sending this message back to the chain, hey, these are my new session keys. And your node will actually check on the chain what is the most recent declaration of your session keys, and it will use those that's in its memory.
Okay. So that's what I actually wanted to understand, that I do not have to really manage or maintain any of these keys. It will be done for me by the node. And all I have to do is basically call an RPC which will generate those keys for me and then return the public half of all 4 of them. And then just to put it in even simpler words, I have to just pass those 4 public keys as parameters to an extrinsic call, and then it will associate those with my controller because the message will be signed with my controller key. And from there on, I'm all set.
Yeah, that's right. There are more advanced validators who want to generate these session keys outside of the client. And so there is a way to inject your session keys into the client if you want to do that. So one of the motivations of doing this is to have backup validators. So if you want 2 validators who have the same pair of session keys, in case one goes offline, the other one can pick up. We really only recommend doing this if you really know what you're doing. If you're listening to this podcast, it's probably not for you. It's great that you want to be online and have a fallback, but the punishment for signing two conflicting blocks is much higher than the punishment for being offline. So if you're not 100% confident in what you're doing, you should let this be managed in the client itself.
Okay.
But there are the tools available if you want to generate these keys and manage them outside the client and inject them into the clients as you choose. You can also do that.
For the scope of our talk and for the concept discussed in this podcast, I think we'll just keep those aside because those are advanced things. And listeners, if you want to really get into those things, reach out to Joe.
Yes.
Okay. So let's move on. I want to understand a little about key management now. At this time, I understand I only have to manage my stash and controller account. The stash can be something like managed using a paper wallet itself because after signing the initial message of linking the controller with it, I don't really need it in an operational way. So I can just put it aside. So key management is only needed, I believe, for controller account. So yes. How do we do that?
Yeah. So right now, our keys are based off SR 25519, and you kind of have to use a desktop wallet or paper wallet right now because we don't have hardware wallet support, although we do have people working on Ledger and Trezor integration. So for Kusama, you're going to have to manage just setting a password and keeping this file on your computer. It's obviously encrypted if you set a password. By the time we launch Polkadot, we should have Ledger and Trezor support so that you can manage these keys with a hardware wallet.
Interesting. Okay. So for at the moment, we do not have HSM support or like hardware wallet support, but we are on our way.
Yeah.
Okay.
And then HSMs kind of move into the validator stuff because it's conceivable to use them for session keys, and some other proof of stake protocols do this. It's also not possible right now because we have 4 session keys and there aren't any HSMs that can handle SR 25519. So part of the rationale behind an HSM is that it has, or part of the design of an HSM is that it has extremely limited memory. And this is by design because it just limits the space for attackers to do anything. And so we can't really make the SR 25519 signatures, certainly not with 4 separate keys in there.
Sure.
So for the moment, we don't have HSM support, although we're working on some alternatives to that.
Okay. So I think that will be communicated and published whenever we have that support coming up, both for HSMs and hardware wallets, I believe.
Yeah.
Okay.
It's part of our roadmap to be able to support not just the in-client management of session keys, but also external, just have the client send out a payload and say, I need this signed, and then you can return it signed however you want. HSMs actually tend to provide a false sense of security because they're just kind of dummy signing oracles. They'll just, whatever you send them, they'll just sign it and send it back to you. And so if you did send, say, 2 different blocks that conflicted with each other, an HSM would just sign them. It doesn't know anything. It doesn't have any logic in it. So some of the more advanced methods actually use like SGX or just an x86 general purpose machine that has some signing logic in it that says, I'll never sign 2 blocks of the same height or something. So everyone kind of jumps at HSM as like the first thing, but it's really not the best way to protect yourself. There are much more secure setups that you can do by implementing some logic around it.
Okay, interesting. So in that case, I think just to clarify one thing, that at this time, nobody's blocked. You can easily go ahead and do your key management for the session keys using the client, and for the controller key using a desktop wallet, or I think we also have browser extension being worked on from our JavaScript team. So I think there are options to manage your keys at the moment.
Yeah, and for the truly paranoid, what we're going to do is once we have our Polkadot.js, which is like our JavaScript tool and website for generating these keys and interacting with Polkadot, once we have it ready for Kusama, and then I'm sure we'll do this again on Polkadot, is that we're going to sign a commit of Polkadot.js with Parity has its own GPG key, and we're going to say, this is a good version of Polkadot.js that you can use. You can put it on a thumb drive or something and use it in a virtual machine or a live booted machine or an air-gapped machine or something, and generate your keys that way. And then you could conceivably just sign your payloads like this, put it in a connected machine, generate your payload, bring it to your air-gapped machine, sign it, bring it back. So there are kind of hardware wallet solutions. It's just a lot more steps than using a ledger.
Okay, so let's move on to the next topic that I wanted to discuss with you is about now getting into some details of the staking side of things, the nominated proof of stake. And then when it comes to stake, then we have staking rewards. And then we have something called slashing as well in Polkadot and Kusama. So let's talk a little bit about that. Let's start with maybe understanding NPOS, nominated proof of stake, a little more.
Yeah, so in NPOS, you're going to have a list of people who want to be validators. And then there are a lot of people, the majority of people, who do not want to be a validator because it takes a lot of work to be a validator, but they still want to capture the inflation of the network. So this is kind of a difference between proof of work and proof of stake networks, is that the only people who capture inflation in proof of work are the actual miners. Whereas in a proof of stake network, depending on how the network is configured, a lot of people can capture parts of this inflation by nominating or delegating or however the network calls it. But if we focus on Polkadot here, it's nominating. And so there's going to be a list of people who want to be validators. And if you do not want to be a validator, then you can nominate somebody. And you can actually nominate a lot of people if you want to. And so our goal is to have equally staked validators. So if we want 100 validators in the network, we want each of them to have 1% of the stake that's behind the validators. And so we let people nominate more than one validator, and we have an algorithm called Fragment that will automatically distribute the nomination stake in the way that optimizes the validator set. So there's really two optimizations that are taking place. What's the best combination of validators and nominators that results in the most amount of dots at stake?
Okay.
And then the second optimization is what is the allocation of those nominators that results in the most even distribution of that.
I want to understand this a little better. So when you say the algorithm automatically decides how you want to distribute your nominations as a nominator, do I have control on who should I nominate? Like, for example, let's say one thing is that the algorithm or the network allows me to nominate multiple validators. And then let's say A, B, C, and D are 4 validators. And I want to nominate them. And I have 10 dots, let's say, or 10 KSMs. So I want to put these 10 KSMs on these 4 validators. Do I have the control to say that I want to give 2 to A and 4 to B and 1 to C and then whatever is remaining to D? Or will the algorithm decide it for me?
No, the algorithm decides that for you.
Okay. So I just have to say that 4 validators I want to nominate. And then these are the dots that I have, and then do your thing.
Yes.
Awesome. That makes it really, really simple. I don't have to really worry about where the money is going.
Yeah.
Okay, cool. So, well, some people worry about that, but it makes it simple.
Yeah.
Yeah. Okay. Now that we know generally how nominated proof of stake works, and even before that, let me rephrase this for our users so that for their understanding that a nominator is anyone holding tokens and can be anyone holding tokens. And a nominee in this case is actually a validator or the next validator selected for the next era or how do we...
Someone who wants to be a validator.
Someone who wants to be a validator. And you can simply choose and decide which are the subset of validators you want to nominate and put your stake behind, and then the algorithm will decide it for you on where it goes and how it gets divided.
Yes.
Now let's move on and talk a little about how do I nominate and how do I ask for nominations, because now we have to clear 2 different roles, and let's get into the operational side of it. If I have tokens and if I know that I want to nominate Joe and Joe's friend and Joe's friend's friend as 3 validators for my stake, how do I tell the system or tell the network that these are my 3 nominees?
Yeah, that's pretty simple. You just sign a message with the address of the validator that you want to nominate. Mm-hmm. And so I believe it's the stash account for the validator, because the controller and session keys can change. Mm-hmm. And so that's all handled through the UI. It sounds complicated, like sign a message of the address of the validator, but in Polkadot.js, there's literally a button that says nominate, and you can choose who you want there.
Okay. So in that case, it's like, if I understood it correctly, that there is extrinsic call exposed, and I think it must be in the staking module in that case.
Yeah.
Yes. Okay. So there is the extrinsic call, which you can call by using any of the UIs which are connected to the network, and then you can set your nominations, and this should be signed by your controller account.
Yeah. So as a nominator, you can still have a stash and controller account. So you shouldn't be putting your stash funds at risk here. Just sign it with your controller account that this is who you want to nominate.
Okay. All right. So that's simple. That's easy, that I can nominate just by calling a API endpoint or just by calling extrinsic on Polkadot or Kusama. Let's talk a little now about rewards. So we talked about staking. Of course, like validators are staking for becoming a validator. Nominators are staking for reaping rewards by not even being a validator. So how do we get rewarded?
Yeah, so this is something where Polkadot diverges from a lot of other proof of stake networks, in that the rewards are actually not proportional to how much you as an individual have at stake. They're proportional to how much total is at stake. And then within that, all of the validators get equal rewards, regardless of who has the most stake. And so we want to have about 50% of the network at stake behind the validators. That's our goal. So then the other 50% of the network is for parachain slot auctions. So we expect parachains to have dots bonded for their parachain slots, and then a small amount as liquid tokens to be traded, transferred, whatever. So we want 50% of the network staked behind the validators. So we just kind of have a curve from 0% at stake to 50% at stake that ramps up with inflation, or the inflation ramps up as the amount at stake ramps up. And that way there's always more rewards as more goes at stake. And then once you pass 50%, they drop off quite dramatically. So there's not much incentive to be a validator or to nominate with your tokens once this goes beyond 50% at stake. So then once the inflation for the network is set, however many dots per era that is gets split evenly among all of the validators. So even if one validator has twice as much at stake as another, they're going to get the same reward. There are two motivations for this. One is kind of from first principles. Validators are doing the same thing. They have the same responsibility. They're voting on things. They're producing blocks. So they're doing equal work. They get paid equally.
Okay.
Our second motivation here is to have all of these validators be equally staked. And so if you're nominating someone, you'd actually want to nominate the lowest staked validator. So if one validator has 100 dots behind it and another one has 500 dots behind it, and as a nominator, you're going to get a percentage of the rewards, you're going to get a much higher percentage of the rewards if you stake the validator with 100 dots behind it. And so it should incent people to nominate the lower staked validators, and that just kind of naturally leads to an evenly staked network.
That is really, really interesting and cool, because in that case, I am being motivated as a nominator. I'm being motivated to put my stake behind the least staked validator so that everybody is equal. And that also helps me get more rewards, because then I have more percentage of stake for that particular individual validator.
Yes.
So let's move on with... let's think about slashing. Let's talk about slashing. So
all right.
We got rewarded. Eventually we'll fuck it up. So what will happen?
Yeah, if you fuck it up, you'll get punished.
Okay.
You have a lot of responsibility as a validator, so you're expected to honor it. But of course, it varies in a lot of different axes here. So this also goes along with keeping an evenly staked network. Slashes are proportional to your amount at stake. So a slash is percentage based, not absolute based. And so if you have a lot of funds at stake behind a validator and it misbehaves, in absolute terms, you're actually going to lose more than a lower staked validator. When it comes to larger validators, these two things together, you can see kind of lead to the conclusion that you should be running multiple validators instead of just staking behind a single one. But if we focus on slashing here, there are a few categories of misbehavior of varying severity. So kind of on the light side would be just being offline. You're supposed to be online. That's kind of your job. But also we recognize that, shit happens. And every once in a while you lose connectivity for a couple minutes or something. So I think we actually give you like one freebie. If you miss a session, it's okay. If you miss 2, you start getting slashed. It's really small. I think like 0.01% or maybe 0.1% of your total stake. It's a little slap on the wrist, and then it actually forces a new election. So you get kicked out of the validator set for the next era, which starts immediately, and then you kind of have to ask to come back in one later. So then punishments kind of increases as you do worse things. So I think like double signing a block, that means signing 2 different blocks that conflict with each other. I think that's like a 10% slash. And then things that attack the network. So like voting on a chain that conflicts with a chain that's already been finalized, these can be slashed up to 100%. And so kind of the motivation behind these 3 levels is, the offline thing, mistakes happen. The double signing thing, it's like you can be running good software, but maybe you made like an infrastructure mistake. You set up 2 nodes with the same keys and they accidentally sign different things. You really shouldn't do that, so you get punished heavily. And then if you do something like vote for a block that conflicts with something that's been marked final, this shows you've actually modified the software. So it's in the Polkadot implementation, not even to import a block that conflicts with the finalized chain. So if you import and vote on a block that conflicts with this chain, you're clearly not running the standard software. And so it's not just like a screw up, it's you're actually trying to attack the network here. And so that gets slashed the heaviest. And then there's another dimension to this, which is the coordination. So if, say, 20% of the network goes offline, it's not going to be slashed 0.01% like if just a single validator goes offline, because it looks like a coordinated attack to slow down the network or even halt it. And so, it could be a coordinated attack. It could also just be negligence, like if all of the validators put their nodes in the same data center or something. We want to avoid that. So we want validators to be conscious of where they're putting their infrastructure and make sure it's really independent, and so that we don't have large chunks of the network going offline together.
Okay. So let me understand that a little better, because I think what you mentioned is, and please correct me and jump in if I rephrase it incorrectly. So when I get rewarded, I get basically rewarded equally along with other validators as a validator, and as a nominator, I get rewarded as per what I have put in a particular validator. So for example, if a validator is getting 10 tokens as a reward, and if I have a staked 10%, then I get 1 token from this. But when it comes to slashing, it's kind of different, because I don't get slashed equally, because it's me who is making the mistake and not the others. So I will be slashed on the basis of percentage. And then there are different scenarios to be considered. Like if this is just missing a block production, then there are different things. Then if it is just missing, for example, vote, then there will be different slashing. And then if I'm trying to attack the network in a way that by signing 2 blocks or something like that, then this will be a completely different blunder altogether.
Yeah.
Okay. So then slashing is really, really a more serious thing. And it's really important to play fair here, because otherwise I'm going to lose a lot of money.
Yeah.
Okay.
And you should be careful who you nominate, because nominators get slashed with their validators.
Oh, okay. So nominators are also like, they will also be seeing the effects of slashing.
Yes.
Okay. And is it also in the same percentage?
Yeah. So
Okay.
it goes across the nominators and the validator.
Okay.
Yeah.
Okay. And how do I know if somebody has been already slashed, or if somebody is not playing fair? For example, is there a dashboard, or is there a plan for something like that where I can go and see, oh, these are the current validators, they have this kind of reputation, they have been always online or not, and so on. So is there something being planned in that direction?
Plan, certainly, which may even be like outside of Parity. But we definitely expect to see some kind of forum or dashboard that reports on validator activity, because all like the slashing stuff is all on chain. It emits events, so you can kind of replay the chain and see what happens. I don't remember if the slashes actually get stored. I mean, you can see the actual account balances change, and then there are events that get emitted for this stuff. So I don't know if we plan to do it, but surely these things emerge.
Yeah, I'm coming from the fact that this will be interesting for nominators because, like you mentioned, that you should be aware of who you are nominating. Then there should be a way of knowing that, like who I'm backing. For example, a criminal record kind of thing or something like that, where I can say that, look, this guy is not doing good. He has been slashed so many times. He has not been sending I am online messages consistently. So there should be, I mean, of course, if nobody's working on it, then this is a good thing to do, I think.
Yeah.
For the listeners, like if somebody is willing to pick something up in the Polkadot ecosystem, this could be something.
Yeah, for sure. If especially if you don't have access to the resources for like the actual, because there's a lot of physical infrastructure in validating. So if you don't have the money or the physical resources to do this, and you're interested in staking and validating, this is totally something that you can just do as a software project. Mm-hmm. And it's really like, it's in the interest of the good validators to create a website like this, right?
Yeah.
To show that they're online.
Absolutely. So we covered staking, reward slashing, and the NPOS side of things. We also discussed a bit about key management, the different accounts, keys, and so on. And then we started with the validator introduction. Now let's actually move right into the process part of things. So we eventually wanted to go with this particular episode of the podcast that when somebody wants to become a validator, what he should be doing. Till now, we were basically building up to this part, understanding different concepts and how things work and everything. But now let's get into the real work stuff. Like if I want to become a validator, first of all, how different is it for me as compared to other proof of stake networks? If I want to become a validator for Kusama or Polkadot, should I be considering something different or should I be expecting something different here?
I think from a setup point of view, it's pretty similar. I mean, DevOps and infrastructure are kind of the same everywhere. Mm-hmm. And so, there are a few differences, like whether you use an HSM or not. But overall, architecture is pretty similar to other proof of stake networks. There's nothing wildly different, which we actually want because we want validators who are competent at validating. And so right now, this is a very niche and new industry. And so the most experienced validators out there are validating on other proof of stake networks. So for the most secure setups, it's kind of nice to have something similar. And these principles like being online and not double signing, these are kind of universal across all proof of stake networks.
Okay, so in that case, listeners, do not worry. There is nothing really, really complicated going on here. And let's jump right into it. So what should I do first if I want to, create a validator node or deploy a validator node in my choice of data center? Then how should I begin? What would be the first step?
Yeah. So I was just talking to someone at the Web3 Summit 1 or 2 days ago, and who's coming up with like kind of one-click deploys for this stuff. So hopefully you won't actually have to do that much. But if we get a little bit into what that one-click deploy would be, you're probably looking at some Sentry nodes in the cloud. And so what a Sentry node is that you don't want to give away the IP address of your actual validator because it'd be very easy to DOS it and just make it go offline. And, it doesn't really give any profit to the attacker. It just makes you lose money because you get slashed. So you don't want your actual validator to be exposed to the network, but it has a lot of work to do. So there's this concept called Sentry nodes, which are just full nodes running in the cloud. And they're the only ones who have permission to connect to your validator. So your validator is not on the public internet. It only has like a VPN connection to some of these full nodes in the cloud. And these could just be like EC2 instances in AWS or Azure or something. And they'll forward messages onto your validator. So if somebody tries to attack one of these by sending, 1 million copies of the same message, these Sentry nodes will check, and they're only going to send one copy of this to the actual validator. And if these Sentry nodes get attacked, it's very easy to spin them up. So you can have a load balancer, auto scale, whatever, that can help distribute the load among different Sentry nodes. And then once you go beyond that, there's the actual validator. And so we recommend running this in like a private data center, or if you have the skills yourself on your own server infrastructure. And yeah, these connect to the Sentry nodes. And eventually this is where you could actually add a third layer for like a signing machine or something behind that. But from a very high level, about all that I think we can say verbally without going to like pencil and paper is that there is kind of like a front line of Sentry nodes that live in the cloud that can be load balanced and scaled. And they're the only ones who have permission to actually talk to your validator and request things to get signed. And your validator sends the messages through those. And that way, nobody else on the network knows where your validator is.
Okay. And my validator can be anywhere in that case, like in the same data center, in a different one, in a different cloud operation, cloud provider, or even on my laptop.
Yeah, I mean, we don't really recommend putting the actual validator in the cloud because then you're kind of leaving your key management up to somebody else, which in most cases, I mean, this is kind of like off blockchain topic, but you know, a lot of small businesses or even medium businesses are like, you know, I don't want to put my information in the cloud because like, how do I know it's secure? And it's like, yeah, Microsoft and Amazon are just better at securing their data centers than you are, probably.
Absolutely.
But you know, in this case, because like a validator is going to have, I mean, literally in Polkadot, millions of dollars at stake behind it. It's perhaps something you don't want to leave up to the cloud. And you know, if you consider it really mission critical, then maybe you want to have it in a private data center or running it yourself.
Okay.
But it is, of course, you know, from a DevOps perspective, it's possible and probably even easier to run the actual validator in the cloud.
Okay. We'll leave that to the listeners and who want to be validators. Let's let them decide where they want to put it. But I think the recommendation is pretty clear that it should be like they should be considering running them themselves, or maybe in a non-cloud data center, a private data center, or if they want to just keep it simple, they can run it anywhere they want.
Yeah.
Okay. Now that was more about the infrastructure and like topology. Like there will be Sentry nodes, they will be talking to the validator and so on. But I think there are some key concepts here that we spoke about earlier, and then let's just bring them back because they are relevant to the process. So if we start from the scratch, let's say, first of all, I will need a stash account.
Yes.
And then I need a controller account. And then the step would be to, connect or associate these accounts with each other by calling an extrinsic. This call should be signed by the stash account, and that will be like connecting these two accounts together. So at this point in time, I have my two accounts.
Yeah.
Then I download the Polkadot or Kusama binary, the node binary, and supply a chain spec file to it, I'm assuming.
If you're on Polkadot or Kusama, that chain spec comes with the binary.
Okay.
Right.
Interesting. Cool. So even simpler. So I download the Polkadot binary, I run the node, and sync it with the network. So at this time, I have a full node running. I have my two accounts, and it's syncing with the network, already synced. And now what I do is I create my session keys by calling an RPC.
Yep.
Right. Now that will return the public parts of all the session keys. Then I take those public parts and call an extrinsic again, which should be signed by my controller account. And this will associate my controller with my session keys.
Yes.
Okay, cool. So at this point in time, I'm all set with my accounts and keys.
Yeah, I think the one thing in between is that before setting your session keys on your controller, you have to also sign an extrinsic from your controller that says, I want to validate.
Okay. So that happens before.
Yes.
Okay. So I have also shown my intention to be a validator by calling a validate function of the staking module. So now I can actually participate in the next election whenever that is happening.
Yeah.
And if I have enough stake and if I have enough nominations behind me, then hopefully I will be elected as a validator. And if not, I should. Now, what should I do if I don't become a validator?
Keep at it.
Okay.
So if you're running multiple validators, you might just have to shut one down and put more of your stake behind a single one. Mm-hmm. Otherwise, I think that's more of a social thing. Find more people to nominate you.
Okay. So basically that's what I wanted to understand, because the validator set will change about a day. And then I can try to become a validator after that, for in any election that I want.
Yeah.
Okay. Now, I became a validator. I started validating. And then, for example, I want to go offline. There is slashing for being offline. So I should not be doing that while I'm a validator. But at the same time, the infrastructure that I'm running my validator node on, or maybe because of some other reasons, I want to go offline for a bit. I want to upgrade the things or do some maintenance or, migrate everything to a new and better place and so on. So for that, I will be looking at some downtime because that's how infrastructure works. What should I do?
Yeah, so if you need to go offline, then you have two options basically. One is to set an extrinsic, it's called chill, which just says I want to stop validating right now. And so I think you still have to finish up the era that you're in, but then in the next election, you'll just be removed from the validator set. And then you can go offline, no punishment or anything. And then once you've done your upgrade and come back online, you just say, I want to validate again, and you're up for election in the next election.
Okay.
If you don't want to have any dropout of the validator set, then what you can do is just have a second validator running, set the session keys on that validator, tell the network that you want to use this new set of session keys, which I think we've covered the double signing thing quite a few times.
Yeah.
Don't put the same keys in two different nodes. Tell the network which session keys you want to use, and then your new validator should pick up, and you can update the old one and switch back. I think you would have to connect it to the same Sentry nodes because, this gets into the networking, but the validators have this DHT of where all the other validators are and how to find them. And so, of course, this can change as you add and remove Sentry nodes. The DHT gets updated, but I think you're probably better off if you can just keep the same Sentry nodes.
Okay.
So everyone knows where to find you.
Okay. Just to rephrase the first and the simpler option for our listeners is that if I have to go offline, if I have to pee or something like that, then it's pretty clear that just by calling the chill extrinsic, I am showing my intention not to validate in the next era. And then as soon as this current era is over, I will be removed from the validator set for the time being. And then I can go offline, do my thing, upgrade my infrastructure and everything, and then come back and apply for being a validator again by calling the validate function.
Yeah.
Okay. So I think that covers the process part that we discussed, that we would want to set up our account. We want to download the binary, create the session keys. We want to show our intention to be a validator. Or actually, it comes before that, because you mentioned that clearly that after downloading the binary and having the node syncing, we want to first say that we want to validate, and then we want to generate the session keys and associate them with the controller account.
Yeah.
Okay. And that makes us, a contender to become a validator in the next election. And then if we get elected, we become one. Cool. So last and final bit that I have here is just to clarify a few things for the listeners is about misconceptions. So there are definitely, because there are so many new concepts, and this is the first time we are actually talking in detail about these things and going to publish them in the open domain. So I also want to talk a little about misconception, like what could be or what are the misconceptions here with these concepts. And if you want to just let the listeners know that this is, you should avoid that.
I would say we covered the number one misconception is just that the validators get equal rewards regardless of stake. I feel like I have this conversation almost every day because it's just different than other proof of stake networks. The other, I wouldn't call it a misconception, is that in Grandpa you're voting on chains, not blocks, which we also mentioned, is just very different from other algorithms in blockchains. It's not block-based, it's chain-based. I don't think there are many others. I mean, the actual infrastructure part is pretty similar to other, non-blockchain, just normal infrastructure.
So I think the primary misconception is only about the slashing and rewards. So rewards are basically equally divided among the validators, and then their nominators take the amount proportional to their stake in a particular validator, while slashing actually happens in percentages, and we have covered that previously. So yeah, that's the major difference, and that should not be taken as a misconception. It's actually a thing, and you should care about it.
Yeah.
Okay. So I think that covers a lot of this thing. Finally, I would like to ask you if there are any do's and don'ts for potential validators, if they should be looking at something and they should not be doing something at all.
Yeah, I think the number one do is take it seriously, because there will be a lot of funds at stake. Proof of stake networks, or not just proof of stake networks, but blockchain networks or even consensus networks are completely economic. Their security is based on how much is at stake, not really much else. And so we expect validators to have a lot of money at stake behind them. And so it's not really like, if you want to play around on testnets and experiment there. But yeah, make sure you're actually taking it seriously when you're on mainnet and have your setup audited or something. Like, don't take anything for granted. As far as don'ts, don't mess up.
Don't be offline.
Yeah, don't be offline. Don't double sign blocks, and don't do bad things like vote on chains that conflict with the finalized chain.
Okay, cool. So I hope listeners, you have listened to that and you got that clearly. Now, I think that's pretty much it from the questions that I collected from our team and from myself as well. And hope this is useful for our listeners who want to jump into validation on Kusama or Polkadot in the future. And thank you so much, Joe, for sharing all this information with us.
Yeah, thanks for having me on the podcast, Gautam.
Yeah, it's yours.
Thanks for listening to Relay Chain. We'd love to keep in touch. Follow us on Twitter at RelayChain or email podcast@parity.io. Our team at Parity includes some of the leading peer-to-peer networking developers, consensus algorithm inventors, blockchain innovators, and Rust developers. If you want to learn more about our work or want to work with us, visit our website at parity.io and sign up for our newsletter at parity.io.